So page 20, we talked about the idea of coterminal angles. And what we discovered with coterminal angles is that if I want to rotate around a circle, I'm always going to end up the same spot, right? I can maybe go 4 or 5 rotations, but there's only a certain there's only certain angles that we're going to keep repeating. So we talked about how, for instance, if I have a 30-degree angle, I have different variations of 30 degrees, right? But 390 is also 30 degrees because if I start at 0 and make my way all the way over to 360 and then add another 30 more, I'm basically where I left off, and I'm still dealing with this 30-degree angle. I could also go the other direction, right? I can go 330 in the clockwise direction, and that's going to also end up giving me this angle here, this 30 degrees. So the big picture here is if I want to find a coterminal angle, basically the same angle, just different rotations, I can just keep adding or subtracting 360 to get to the same angle measure location as what I started with. Okay. Now that also applies for radians as well. So if something is in radian form, I can add or subtract 2 pi because 2 pi and 360 are the same thing. It's just one's in degree form and the other is in radian form. Okay. So radian measure we're not as familiar with. Feels more abstract, but the same idea applies. I can take any angle in radian form, add 2 pi, and it'll create a different variation. That's the same measure as I started before, just a different number of rotations out, either positive or negative direction. Yes.
How do you get from 2 pi to 12 over 6?
Okay, good. So how do I get 2 pi to be 12 over 6? Now, if I want to add fractions, I can't add by hand without getting a common denominator. So 2 pi is the same thing as 2 pi over 1. And my common denominator is a 6. So if I want 2 pi with a denominator of 6, I got to make the 6 times 2 to be 12, because 12 over 6 is 2. So that's the whole thing. Yeah, just trying to get common denominator. Now, on the quiz, you get to use a calculator, so you could just make the calculator add and subtract fractions for you, and it'll get you to that fraction value. Okay. So we also talked about on the bottom of page 20, example 2, how we can always, if I want to find a positive and a negative coterminal angle, I can just keep on adding 360 until I get to the positive or the negative. But the harder part is trying to figure out what quadrant is the angle line. And it's easiest to identify which quadrant if I'm able to get my angle down to something that I can recognize. So between 0 and 360. So I can always add or subtract 360 until I get to something that I recognize. But for B, we talked about how when you have a really, really large angle, rather than keep adding 360 over and over again, if you divide by 360, you can have an idea how many rotations it's going to take, and then take that, multiply by 360. And if I add that number, I can get to my recognizable degree measure a little faster. Okay, so we talked about that yesterday. And so today, we're going to review a bit more with coterminal angles, but the last topic that I want to go over is called reference angles. Reference angles. So let's go to page 21 and let's talk about definitions. some of the words were cut off, so I'm gonna show that. So a reference angle is the angle formed by the terminal side of the angle. That's the ending side of the angle. And the closest part of the, and then it got cut off here. It should say the x-axis, the closest part of the x-axis. And we're going to give a special notation for reference angle. And we're going to call it theta prime. So that theta with that little exponent comma there, we call that prime. So the way we say it is, we say theta prime. So that's how we call that notation. Theta with that little apostrophe, theta prime. So that's the notation that we're going to give for reference angle. Okay, so let me show you a couple of examples, and I may redraw some of these so that you can see it more clearly. Okay, so reference angle is the angle formed, but another important thing is that reference angle is an angle measure is an acute angle. Let me put that additional information here. Reference angle is a positive acute angle what that means is that my theta prime is going to be a value, positive number between 0 and 90. That's what a reference angle is. Okay. Or if you're in radian form, it's between 0 and pi over 2. Or 1/2 pi. So let's start off with the easy one here. 46 degrees. 46 degrees is in the first quadrant. The quadrant is going to be helpful down the road. So I'm just going to list that out. Quadrant 1. Now 46 degrees is already an acute angle. It's already positive. So when something is in the first quadrant, your reference angle is the same as your angle. There's not going to be any changes here. So my theta prime is going to be 46 degrees. It's already an acute angle. It's already positive. It's already between 0 and 90. So when you have a first quadrant degree measure, you're not going to have to make any adjustments. Okay, that's going to be the angle. That's going to be a reference angle. Okay. Let me do part C first because I want to get the degrees first, and then we can talk about radians. Now, let's look at 253 degrees. Okay. Which quadrant is 253 in? Third quadrant. Okay, so I'll say Q3. Now the arrows are a little bit it's just a little confusing here. So I just want us to draw that angle measure here. 253 is in the third quadrant. So go ahead and put that there. I'm sorry. Okay, the reason why it's not in the second quadrant is because second quadrant is between 90 and 180. Third quadrant is between 180 and 270. And 253 is between 180 and 270. So, yes.
Oh, good. 253 is in the.
It's in the third quadrant. So 253 is going to be this angle here. Yeah. But all those arrows and circle, let's not worry about that right now. So I know I may have, it's not as accurate as I could have it. I should have it further closer to the y-axis. So okay, so just go ahead and redraw it. Okay, because they're showing you a couple of things here that the 253 is measured from here all the way to here. So that's what this big arrow is doing. It's just telling you that this angle is the 253, right? Because you're measuring it from 0 degrees. Now, a reference angle, okay, is the angle formed by the terminal side of the angle. So that's here. I'm going to highlight that angle, that terminal side. And the closest part of the x-axis. So the closest part of the x-axis is over here on the left side. So the reference angle is this piece right there. It's just what is the measure of that acute angle between the 180 degree and the 253. So if I want to find what that acute angle is, I'm going to subtract these 2 degrees. So this is 253, this is 180, and I'm just going to subtract those 2 degree measures. Okay, so what's 253 minus 180? 73. And we put theta prime, and let's confirm that we're meeting our conditions. Has to be a positive acute angle, which 73 is, and it's between 0 and 90, which it is. Yeah, question?
I was just gonna ask, why, can't it be to the other, like, y-axis?
Right, so, when we're talking about, reference angle, later on, it's gonna come in handy, but, we're always measuring with the x-axis. Yeah, that's just, there's a consistency to it that we're gonna see later on. We're never gonna be touching the y-axis. We're always measuring with the x-axis. Okay. Always compare with the x-axis. Okay, how to get a 180? So the 180 is the x-axis on the left side. So anything that is right here is considered the 180 degree mark. Okay. So I need to find the closest x-axis, which is here. So we know that this side is 180, this is 253, and then we're just going to subtract those two. Okay. Now, this is a little more complicated here, 3 pi over 4. Okay. Now, they're drawing it for us. 3 pi over 4, which quadrant is that in? Second quadrant. Okay, so we'll put Q2. So I'm going to just draw this again so that we're not distracted by so many different things here. Again, what is the closest x-axis to that terminal side? The 180, right? But we don't want to do 180. We want to do a radian. So what's the radian version of 180? All right, good. So I'm going to highlight that here. This is, I'm looking at that angle between those two. This is the 180 degree line, but we want the radian version of it, so we'll do pi. I want to find that acute angle, so I'm going to subtract the smaller from the larger. So I'm going to do pi minus 3/4 pi. Now, the way that you would do it, without dealing with the pi's is you would just, if you do pi minus 3/4 pi, that's the same thing as if you just drop the pi's out and just say 1 minus 3/4. So what's 1 minus 3/4? Yeah. Ask that question again.
Like, I thought we were doing 3/4 pi, minus.
Minus pi, okay.
Yeah.
Good. So the reason why we do pi minus 3/4 pi and not 3/4 pi minus pi is because what acute angle are we looking for? We're looking for a positive acute angle. So if I do the smaller minus the larger, I'm always going to end up with a negative. Now you could do that. You can do that and just adjust it and drop the negative and make it positive. That will work too. So 1 minus 3/4 is, say it again. 1/4. We're going to add that pi back in. So our reference angle is pi over 4. Now, pi over 4 is 1/4. 1/4 is between 0 and 1/2. So we're safe. That is a reference angle that falls into our restriction.
You can also write 1/4 pi.
You can also say, yeah, you can also write 1/4 pi, but typically I say pi over 4, but that's fine. Yeah, they're one and the same as long as you know the different variations are good. Okay, so we're seeing an example of each quadrant. Okay, so when you're dealing with quadrant 1, you leave it alone. Okay, nothing changes. It's already a reference angle. If something is in the second quadrant, you know you got to deal with the 180-degree line, either pi or 180, depending on which units you're in. If you're in the third quadrant, you're also dealing with the 180 line, and you're also subtracting from it. Now look at part D here. 7/4 pi is drawn for you. Which quadrant is that measure in? Fourth quadrant. Okay, so I'll put Q4. And I'll just go ahead and draw it without all the distracting symbols there. Good. How do you know which quadrant it's in? For now, you can always convert it to degree form and then have it be more recognizable. Yeah, but that's a good question that I can kind of put in my diagram here. Okay, 0 is same thing as 0. I'll put this in here. 360 is same thing as 2 pi. 90 is pi over 2 or 1/2 pi. 180 is pi. And 270 is 3/2 pi or 1.5 pi. So you're basically looking at the fraction. Where does the fraction lie? If the fraction is between 0 and 1/2, then it's going to be in the first quadrant. If your fraction is between 1/2 and 1, it'll be in the second quadrant. If your fraction is between 1 and 1.5, that's 3/2 of 1.5, then it's in the third quadrant. If your fractional value is between 1.5 and 2, then it's in the fourth quadrant. So if you look at 7/4, 7/4 is more than 1.5, but less than 2. So that's why it's in the fourth quadrant. If you just do a quick check here, 7/4 is decimal is 1.75. That's more than 1.5, but less than 2. So you can just look at the fraction to help you know where it's going to land. Okay? Now, I'll go ahead and put that there, 7/4. Now, what's the closest x-axis here? It's this positive x-axis, right? Okay. We don't want to pick the one on the 180 side because that's too far away. We want to pick the closest x-axis that we can find because that's what's going to give us our acute angle. Now, what's the radian measure of this side here? 2 pi. Okay, we gotta find something larger. We don't want to use 0 we're in the fourth quadrant already. We want to get to that 360 line. And so we want to use 2 pi. So we do larger minus smaller, and that will guarantee us that we get that acute angle. So our reference angle is 2 pi minus 7/4 pi. In your calculator, you're just going to do 2 minus 7/4. You're not going to you're not going to put the pi in the calculator. So 2 minus 7/4, you can do this without your calculator. You can do common denominator. 8/4 minus 7/4 gives you what? 5/4, 1/4. So my theta prime is pi/4. Your reference angle is always positive, always less than 1/2 or less than 90 degrees. So that's the strategy involving reference angle. I have a list of steps here, and I want to have you guys copy this down. If you can find some space, okay. But any questions so far? Okay, so I'm gonna highlight the steps here that we're gonna take for more complicated problems, as well as the steps that we're gonna take. Okay? So to find a reference angle, first is sometimes the angle given to you is not within the easy range, right? Let's say the angle given to you is like 460 or -20. What you're going to do is you're going to find that coterminal angle that you can at least recognize. Okay? Get that angle. If they give you a starting angle, get that angle to be something that you can recognize. So either add or subtract 360 or add or subtract 2 pi to get into that range that you can look at and know which quadrant you're in, because that's the important thing. You got to be able to look at the angle and know which quadrant you're in. Otherwise, you're kind of lost. So if there's any beginning steps that we need to take that, and we'll do those types of problems next. Okay. But sometimes we have to adjust and find an angle that we can recognize by either adding or subtracting 360 or adding, subtracting 2 pi. So once you are looking at an angle that is in these easy to identify ranges, then figure out which quadrant you're living in. Okay, are you in first quadrant, second quadrant, third, or fourth quadrant? Because depending on which quadrant, the way you find reference angle is going to be different. So the easiest one is quadrant 1. If you're in quadrant 1, then what your angle measure is your reference angle. So there's not going to be any changes. Okay, it's easy. First quadrant is easy. There's no changes needed to find the reference angle because your angle is already between 0 and 90. Right? Now, if you're in quadrant 2, then the closest x-axis is going to be your 180-degree line or your pi line. So you take your pi or take that 180 and you subtract. You do larger minus smaller. If you're in the second quadrant, your angle measure will always be smaller than 180. So you're always going to do 180 minus that theta or pi minus that angle. If you accidentally mix this up, it's okay. Because if you see a negative, just drop the negative, right? So it's just going to be the positive angle measure between that and the x-axis. If you're in the third quadrant, very similar. Your closest x-axis is still the 180-degree line. So you just do that angle minus 180 or theta minus pi. Again, the important thing is that you recognize which angle measure to use. If you accidentally subtract the smaller minus the larger, it's okay. You'll just see that negative and you just drop the negative. Reference angle always has to be positive. And then your fourth quadrant is going to be between 270 and 360. So if you're in the fourth quadrant, you've got to find the closest x-axis. But we don't want to use 0, right? 0 is too small. You want an angle that's larger. So you want to take the 360-degree variation. So you do 360 minus that angle. That will get you something between 0 and 90. Or 2 pi minus that angle. Okay, so if we follow these steps, we'll be able to find any reference angle that is thrown at us. Okay. So today we're just mainly going to focus on practicing this and making sure we're comfortable with finding the reference angle. Any questions? All right, I'll leave this up for another second, and we'll look at part E and F, where we have to take those initial steps before we can do the reference angle. All right, everybody good? Now for part E, let's pretend like we can't see the diagram. I think the diagram is a little confusing. Let's just look at it, read it, but then let's not worry. We're going to create our own diagram, okay? We'll create our own diagram. So we want to find a reference angle for 487 degrees. So first thing is it an easy to recognize degree method? Doesn't live in the range that that's easy for us to identify. So what can I do to get that 487 into something that I can quickly identify? Subtract what? 360, right? I want to get that 487 into that easy range. Okay, so 487 minus 360. Okay, what does that give us? Okay, 127. Okay, so now we're going to be working with our 127. We're not going to pay attention to 47 anymore because we have a coterminal angle. So 47 is the same thing as 127, just a different rotation or more rotations around the circle. Okay, let's look at 127. Which quadrant is 127 in? Second quadrant, yeah, because 127 is between 90 and 180.
Why do we need to subtract from 360?
I think it's pretty relevant.
Yeah, because 47, can you tell by looking at 47 what quadrant it's in?
Right.
It's kind of hard to tell, right? So I can create, I can find an easier version of that degree measure by subtracting 360. Because anything that's 360 away is the same angle measure, just a different rotation. So now that I have an easier version of the problem, I can just draw a quick picture. And what's the closest x-axis I'm going to use? 180. So I'm just going to find that difference between 180 and 127. And I should be able to arrive at an angle measure that's cleanly between 0 and 90. What's 180 minus 127? 53. So we're going to name it theta prime. 53 degrees. So again, if we follow these steps, we should be able to handle any situation that is thrown at us. Questions? Okay, good. Let's try a problem that is in radian mode. Okay. Now, technically, you could convert this into degree mode and then do everything in terms of degrees and then bring it back in terms of radians. But we're just going to practice leaving it in radian form because you do have your calculator. You can just make the calculator do the adding the fractions if you want. Okay. So first things first, is this something that we can easily recognize? It's negative, right? And it's not between 0 and 2 pi. So we know that we can get to a coterminal angle that's easier to work with by doing what? What can I add to it? 2 pi, good. I can always get a different variation of that measure by adding 2 pi. you can use your calculator, or you can do this by hand. You can do plus 6/3, right? That's a common denominator. And I get -7/3, still not between 0 and 2, so I can keep adding 6/3. -1/3, okay, still not there. Again, you can just keep adding 2 until you get to something that is cleanly between 0 and 2, 0 and 2 pi. So now I get 5/3. And 5/3 pi is something between 0 and 2. And if you look at that fraction, 5/3 is between 1.5 and 2. If you look at 5/3 fraction, it's 1.6. So 1.6 is between 1.5 and 2. So we have an idea which quadrant is this in. Fourth quadrant, right? 1.6 is between 1.5 and 2. That's in the fourth quadrant. So I'll say Q for. Yes, question.
How did you get from 5/3?
Right, so if enter 5/3 into your calculator. And then you can hit this fractional button, and it'll convert that 5/3 into a decimal. And you get 1.6, right? Good, so first quadrant is between 0 and 1/2 and 0.5. Second quadrant is between 0.5 and 1. Third quadrant is between 1 and 1.5. Fourth quadrant is between 1.5 and 2. And I'll write that there. 3/2, the same thing as 1.5. Yeah, so if you just look at the fraction or the decimal value, you'll be able to pinpoint which quadrant you're in, and if you're in radian form. Okay, so I just kept having to add 2 pi because I had to do it multiple times to get into something that is out of the negatives. But now that I'm in the fourth quadrant with the 5/3 pi, I can follow my steps, right? So if I'm in the fourth quadrant, take the closest x-axis, which is 2 pi, and subtract that with the 5/3. So just worry about the fraction. What's 2 minus 5/3? 1/3. And 1/3, we can attach the pi, 1/3 pi or pi/3. And 1/3 is cleanly between 0 and 1/2, or between 0 and pi/2. So we know it is a reference angle that fulfills our condition. Okay. But yeah, question. We did.
To the 5/3.
We didn't, because the 5/3 is already between 0 and 2 pi, so we're safe. We don't have to, once we recognize something, we're not gonna add 2 pi anymore, because then we're gonna be outside our range.
So what do we subtract?
We subtract 2 pi, so.
Okay,
Right, so once you get to your angle measure that is clean, then you can subtract from 2 pi to get to that reference angle.
How do you know what to add or subtract?
How do you know when to add or subtract? You mean once you have the angle to work with? It depends which quadrant you're in. So in the first quadrant, don't do anything. Second quadrant, you want to do the larger minus the smaller. So that's how you know which comes first. Then here in the third quadrant, you're going to be more than 180, so it's going to be your angle minus 180. In the fourth quadrant, you got to find an angle larger than any angle that you have here, so you're going to use 360. So you're always playing with either 180 or 360. Okay. And you're never dealing with 90 and 270. Okay, so never work with the y-axis. That's not the reference angle. We got to subtract from the x-axis and not with the y-axis. That's another important thing that we got to be careful with. That we don't look at the angle and say, okay, it's close to 90, so I'm going to subtract 90. gotta use either 180 or 360. Um, hey, let's see. Okay, let's do one of each on page 22 so that we can get some of the practice that we need here. Let's do 19 and 24. And then at the bottom, we will do 21 and 20. So 19, 24 from the top, 20 and 21 from below. And I will work on the problems as the same time that you guys do, so we can kind of just see if we're matching up. So the direction here is identify all angles that are coterminal with a given angle. Okay, there's a certain notation that's involved with it. I'm gonna let's ignore that part for now. However, I do want us to draw one positive and one coterminal angle with a given angle. So if I want to find another coterminal angle that's negative, I can subtract 360. If I want to find a positive one, I can add 360. And then we're just going to do a quick, very rough sketch so that we kind of have an idea which quadrant it's in. So I have a negative coterminal angle. I have a positive coterminal angle. These are all the same measures as -75, just a different rotation around the circle. 285, which quadrant is that in? Fourth, right? You see 270 is down here, 360 is here. Clearly between 270 and 360. So just go ahead and put that angle measure there. And just call it quadrant 4. Okay, let's practice one with radian form. Any questions here?
Yeah. Why do we not draw -4? Just not like draw.
We could, it's just. We would go this way around, but it's the same angle measure, so as long as you do one of them, that's fine. It's just the same degree, it's just I'm starting here and I'm making my way around here, but I'm just gonna end up in the same spot. These are all the same. Yeah, okay. 24. Okay, let's practice working with radian form. So if I want to find a negative and positive coterminal angle, instead of adding or subtracting 360, I'm going to add and subtract what? 2. Yeah, add 2. Add or subtract 2 pi. And again, just make the calculator add the fractions. You don't put pi in the calculator. Okay. I have a positive coterminal and I have a negative coterminal. Look at that fraction value, 23 over 12. What's the decimal version of that? Without the pi. Without the pi. Without the pi, though, just the fraction. 1.9, right? So 1.9, which quadrant is that going to be in? Fourth, right? Because 1.9 is between 1.5 and 2. So we know it's going to be the fourth quadrant. (20 and 21). Now we're going to find the reference angle. Say it again. Quadrant 1. Which problem are you talking about? 24. So 24, we're in radian form. So 23 over 12, that's 1.9. So 1.9 is between 1.5 and 2. Right, so if you're in radian, now if you convert this to degrees, you're going to see that it's going to be like around 350 degrees. So that's in the fourth quadrant. So you can always have that conversion if you really want to see something in degree form. Okay, so reference angle number 20. So again, here are the steps. If you don't recognize a reference, or if you don't recognize a measure in radian or degree mode, you can always subtract 2 pi or subtract 360 to get it to something that is between either 0 and 2 pi or between 0 and 360. So 11 over 3 is a little bit large, right? Okay. Now it feels more recognizable, right? 5 pi over 3 is which quadrant? We got it to between 0 and 2 pi. We know which quadrant it's in. So we know which steps to take. Last one, 21. Because I want a reference angle. So to get a reference angle, I gotta take whatever's in my fourth quadrant and subtract from 2 pi. Because 5/3 pi is too big, right? I gotta be between 0 and pi over 2, and 5/3 pi is too big. So if something is living in the fourth quadrant, you gotta make sure you subtract. Okay, last one here. Let me finish this here. -45 plus 360. Okay, good. You come up and get your. Yeah, I'll check this tomorrow, but so if you're following along, that's great. Tomorrow we'll do quiz review, and it's just going to be going over converting from degrees to radians, vice versa, reference angle, coterminal line. And I'll give you a quiz review tomorrow. Quiz is Friday, yeah. Quiz is Friday. Just take a pass.
Okay. I'm getting into radians of 20.
Yeah.
Radians typically.
I like to kind of think about it.
I'll just wait, there's 2 minutes.
Okay,
So for the quiz this Friday, is it also on the stuff from last year?
just this.
Alright.
No.